Thanks. Hello, everyone. Welcome to our talks. We are going to talk about maybe not the sexiest theme of this convention, is security, but it's one of the most important topics if we want to put anything in production. So, sorry. So we are going to talk about big data and security. So we are going to talk about Kerberos. And to lead us from all this talk, we are going to follow this index. We started talking with a briefly introduction of Kerberos. Later, we're going to explain our particular use case that we have to face it in order to satisfy your company. And then we describe our solution, which changes we have to do in Spark Core and Spark SQL in order to accomplish this use case. And hopefully, if we have enough time, we're going to show you a live demo of our solution, so cross finger that everything works okay. But let me introduce myself a little bit. I'm Jorge Lopez-Malla. As the speaker told you, I'm in charge of the big data training in Stratio, and also I have working in big data from almost 6 years, and specifically in Spark since 3 years ago when I started working in Stratio with awesome co-workers like Abel that will introduce himself.
That's mine. I'm Abel. I've been working more or less for 10 years developing high concurrency systems. There are some stickers on the screen, and those are some technologies that I put on production in the last 3 years ago. So we work at Stratio. Stratio is our company, and we have a big goal that is the digital transformation of the companies. So we help these companies on this challenge. And how? We have our product. It's based in 3 main ideas: the data as the center, platform as a service, and security. Then mixing these 3 concepts, we have Stratio data-centric. It's built on top of DCOS, Mesosphere DCOS, on open source version. And we work it to put inside secure data storage and unified security solution also. Then we can start with the topic of this talk. I'm going to introduce quickly Kerberos. There was a talk yesterday about it. Probably the speaker explained it better than me, but I'm going to try. What is Kerberos? Kerberos is an authentication protocol. It's safe. It provides us a single sign-on. It's trust-based, and provides us mutual authentication. So if we want to relay our security on a firewall-based system, we need to have something like that. As a single sign-on, with the client has a session with Kerberos, then it has a session with all the services, mostly transparently. So, key concept about Kerberos, client server. I think you need an explanation. Principal is the client or service name. It's identified uniquely across the system. Realm identify the environment. Usually it's in uppercase. KDC is the key distribution center. It's the actor who manages the tickets across the realm or the environment. Ticket, the TGT is the ticket which has the client session, and TGS is the ticket which has the client service session. So how it works? A client will drive their credentials and perform a session request, a TGT request. If KDC is all is valid, and then return their session as TGT. Client request a TGS to go to an application. or a service with the TGT as param, and KDC returns this TGS. Then with the TGS, the client can go to the service and establish a secure connection. It's a quick explanation about Kerberos. Then we have a little bit more complicated scenario there. We have a client, a service, a backend, and our KDC. And you can see that the authentication is made one by one. Services know about clients, and backend only know about services. But what if we want to have client permission level at the backend? Pues we need impersonation. Impersonation, briefly, I can say that is use a service in the name of other people, other client, or other service. So in the following scenario, the client make a request to the service make a request to the backend, and if you want to have user level permission or client level permissions at the backend, you need to impersonate the user. This is more or less an introduction to our use case.
So, our use case, the main reason that brings Abel and I here and why he and I are working on this solution since the beginning of this summer is the use case is cross-data, structured cross-data. Cross-data is nothing more or nothing else than a distributed framework and generally purpose computing system powered by Spark. So this means that cross-data is going to use Spark SQL in order to interpret the different queries that the final storage system cannot make. For example, if you want to use a join in Cassandra, they're going to use Spark SQL. If you want to do a select from Cassandra, they're going to use only the native libraries and the native connector of Cassandra. So cross-data can be used either as a library or as a server. Our use case is going to be focused on cross-data as a server. What is the main particularity of cross-data as a server? That several users are going to use the same cross-data server at the same time. So this means that several users are going to use the same Spark context in the same time. This is quite a difficult question in order to accomplish the security. So let me introduce you an example of a typical use of cross-data as a server. We have the typical picture, the initial picture. We have resource master. We don't know which resource master. Cross-data can use the three different resource masters of Spark: Mesos, standalone, or yarn. So they start and they running its worker, and as you can see, cross-data server authenticates itself in Kerberos. So someone opens a cross-data cell, and this starts a Spark driver in the cross-data server. The blue lines represent the user. So as you can see, the user that launched this executor is cross-data server. So the person that starts the cell makes a query, a simple one in this case. This query is sent to the cross-data server, so a Spark driver will interpret this query and communicates with, in this case, Hadoop file system in order to get the meta information needed to accomplish its workflow, making its partition and doing whatever they have to do. This partition will cover in tasks send it to the executor, and the executor make its own magic, communicate it with the storage system, with Hadoop file system loading or storing data, and retrieve the results of the query to a Spark driver that is allocated in the cross-data server, and this result will be returning to the user and sent in form of a table. So as you can see, although we have a particular use case, is basically the usual behavior of Spark. So we think that if we cover this use case, we can cover a lot of different use cases. But what happens when we put cross-data in production? We have to accomplish the AAA. We have to authenticate our process, authorize the user in the final storage system, and we have to make some audit. What is the problem with all of this? That the authorization in the final storage system has to be done by the user that launched the query, not cross-data server. So we come with Kerberos and impersonation, as Abel has told you before, and we are going to talk right now of how we accomplish this.
Then we are going to present or to introduce you to our Kerberos impersonation or proxy user solution. Then what we need to make it run. We need a real user which can be impersonated. It's a kind of run that we need to make. We have to make these user credentials and the Hadoop client configuration accessible for all the cluster machines. And finally, we need to create a home per user in HDFS. So as a brief introduction to our solution, we need to recap some Spark concepts. Spark access to the storage in both sides, driver and executor. And no matter if we are talking about RDD API or Spark SQL, and the executor runs only tasks, and streaming rely on the same APIs that the rest. It works fine without problems. Then we have code. It's our first utility. It's manage all the user about Kerberos, and then we can see the setting, a setter for the proxy user, getter that choose if you want to have the real or the proxy user, and the configuration. The configuration, it's valid to choose if Kerberos support is enabled or not also. We have developed also some wrappers to put in only one place the Kerberos magic. So we have only one point to touch if we need to make some change. We also plan to make plugins for this behavior. So in the future, you can use Kerberos or whatever security stuff.
So, as Abel has already told you, we have to wrap both sides of Spark, driver and executor side. The first thing that comes to our mind was when Spark are going to interact with the storage system in driver side. Both Spark Core and Spark SQL with interact in the process of load information and writing information. So we started explaining about the Spark Core interaction with the RDD API. When RDD are going to interact with the final storage system, when it gets its own partition. The method that will do us is get partition, but the only method in the RDD API that execute this method, that is the one that you can overwrite if you want to do a particularly RDD like the Cassandra ones or whatever, is this method, the method partition. Okay, so if we wrap this, we wrap everything, every RDD in the Spark implementation. So when we started with this solution, we think, okay, if we wrap the load, we have everything wrapped, because as we can say, we have everything wrapped in the driver side, because as all of you know, the real interaction with the storage system will be allocated in the executor side. But we have a surprise when we decide to save an RDD. Spark do some previous interaction with the storage system in the writing process. For example, for Parquet or whatever introduction that whatever RDD that is going to store data in HDFS, the driver will create the output path. So we need to grab this method too. So once we have all the interaction with the Spark Core API, we started with Spark SQL. That is our main purpose because cross data is all about SQL. The first surprise is that in Spark 2.0 we have a default catalog. This default catalog already exists, is in-memory catalog, and interacts with the file system. As we need Hadoop file system as our primary file system, we have to grab every method in this place. And we have to do it with the real user, not the impersonal one. Why? Because they're going to, these classes is going to read all the table of our catalog. So we need to have access to all the different tables. Okay. So when we have this wrapped, we say we are going to find where in all the Spark code Spark read information from a storage system. It's quite simple. It's in this place, data frame reader. Although this data frame reader also is going to be used in dataset. So if we wrap this place, we have everything wrapped. As you can see in the slide, we get the user from the extra option of our data frame. We're going to show you this in the demo, but it's quite simple of getting this user and quite transparent for the user. So when we have the load information already wrapped, we search the saving information, the writing method, and it's right here in data frame writer. It's quite simple too. We wrap all the inner write method and executed it in a secured way. Sorry, using the wrapped that Abel has already told you. And this is when the real magic happens. The black magic instead. The scheduler. This is the class that determines the task associated to a stage, and we need to execute each of these tasks, with a different user. But the same user, all the tasks belonging to the same stage are going to be executed by the same user. So, as you can see, the first thing that we do is reading the proxy user from a global variable, and then when the stage is separately in several tasks, we put this user in the properties file, in the properties map that is going to be sent to the executor side. So with these simple aggregations, we can make that the executor can be executed by the proxy user, not the real ones. And this is going to be explained by Abel.
Okay. The final part of this implementation is the executor side. So we can see the wrapper in task class. We get the user by taking from the properties map and then wrap the task. Doing it here, we not need to touch all the implementation of task. We only have one point to touch in the executor side. So if you want to be it on live, we have the demo.
So please pray for the demo gods. But before we put the demo, if something was wrong, I want to say that we are hiring. So take this before the demo. Okay. So let me show you the code, and please Pray for me. I don't want it to be fired. We have shoe machines. Do you read the code, or I need to put a bigger source? Maybe a bigger source? Okay. So this is Spanish. Someone want to learn something? Okay. Well, maybe it's too big, but you can read it. Okay. In the left side, we are going to interact with Spark. In the right side, we are going to interact with HDFS. Let me show you first that we have what we have in HDFS right now. We have 3 folders with 3 different users. One is me, Jorge, another is Abel, and we have a Spark right here. So let's start our implementation. Okay, as you can see, as Abel has said to you, we have two new configuration parameters, Kerberos GitHub and Kerberos principal. And we are going to be launched queries to standalone resource manager. This is launch a job. Okay, it's work. Right now, your praise are listen for the demo gods. Thank you. We create a case class in order to make all this demo. Is the class person. It's not a very difficulty one, so all of you can follow the demo. So we are going to create a data set with person called Abel, and we are going to rewrite this data set in the following path, Spark standalone, to show that this work we always use relative path, never absolute path, okay? And this option will determine which user are going to use. In this case, Abel. So I put intro, I prayed a lot right now, and the stage is working, please working, yeah. And if we come to HDFS and we execute this query, we can see right now that Abel has some information writing right now, and the user that is writing this information is Abel. And just to be sure, I don't say it in the first show of HDFS. Only user has access to these folders. So if I can write anything here, it's because I'm the right user. So we have one user. This is common use. This is nothing spectacular. So we are going to. Sorry, I don't know. Okay. So right now it comes magic. Let's say that another user, for instance me, are going to write anything in HDFS, right? We have this person, it's called Jorge, it's a little bit older than Abel, but quite handsome, but I'm going to use option user Jorge, okay? And we save it. We save it, right now it's more fast. It's faster. And if we change user from Abel to Jorge, sorry, this is a live demo. As you can see, we have the proper information waiting with the proper user. So right now, we already have 2 different users using the same Spark context. This is something that is not in the Apache Spark implementation, so we can accomplish our use case. But we have to prove that not only we can write, we can read it too. So, sorry, we are going to read this information using the RDD API. To do this, we have to import our utility classes that Abel has already told you about it, and set the proxy user. In this case, will be Abel. Okay, we have the proxy user setting. So if we want to read Abel information using an RDD, sorry about the... Oh, fuck. Sorry, I put Ctrl Z. It's a live demo, something has to happen. Okay, so I import the Kerberos user and put it in Abel. Okay, so if I read using Spark RDD API the information, they have to retrieve me Abel, and he said that is 31. So currently we are so good. But what happened we try to read some information that Abel hasn't have any permission, like mine. Okay. As you can see, we are reading a text file that Abel hasn't have any permission. So we came with an exception that in this font, I don't know if, yeah. Permission denied, user Abel cannot read my proper information. So we manage all this data, but we manage in standalone. Can we manage this in using Mesos? So I think that we can. So, I'm already out. And if we change the master, it's allocated in another host. Sorry for this delay. This is executing the Spark configuration. We started with the job, and we are only trying to read the information using RDDs, okay? Because we are running out of time. Out. Oh, okay. I let adopt. Okay, so the user right now is Jorge, and we are going to read my information. Okay, we read it and we try it with Abel. I want to show myself. And we have failed because we don't have the proper permission. So right now we show you our presentation, and we want to share with you some next step, but we are running out of time. Only say that we have a peer right now with all of this. So if you like this talk and this code, please enter and interact. And I'm running out of time and we don't have time for questions. But if you want to,
they'll be available for if you have any more questions. But we have to conclude this session. Thank you, Abel and Jorge. Thank you for your talk.
Thank you.
Please give them a big hand.
yes.